third chapter of Principles of Digital Electronics, that is combinational circuits. And in this video we are going to learn about the multiplexer's circuit, that is 2:1 multiplexer. Multiplexer is also called as a data selector. So multiplexer, this is a special type of combinational circuit, and here the block diagram of N-2-1 or a N-2-1 multiplexer is shown over here. So this is the N-2-1 or N-2-1 multiplexer. MUX is the short form of a multiplexer. So here n number of inputs are there from D0, D1, D2 to Dn-1. So there are n number inputs are available, and there are m select lines are there. So these are number of inputs are n, and this number of select lines are denoted by m. So these select lines are used to select one input out of this n-1 inputs. So how we can select or how we can decide the number of select lines for the particular number of input lines? So it is given by the equation 2 raised to m equal to n. N is nothing but the number of inputs, and m is nothing but the number of select lines. For example, if n equal to 4, suppose there are 4 number of inputs to this multiplexer. So how many select lines are required to select these 4 inputs? So we have equation 2 raised to m equal to n. So here 2 raised to m equal to 4. So we have to decide the value of this m. So 2 raised to 2 is nothing but a 4. So here number of select lines are equal to 2. So in this way we can find the required number of select lines to select the particular number of inputs. Another input is given to this is E, that is enable input. So this enable input is an active low input. That means if we apply 0 to this input, then it will be activated. This is actually used to cascade the number of multiplexers, and it is also used to activate this multiplexer chip. So here only one output is available for this multiplexer. So here the block diagram of this is given. These are the number of inputs. So here the one switch is available at the output, and this switch will rotate and select one input at a time, and whatever data available at that input, that will be then transmitted or that will be available on the output line. So which input is select, or which this switch must be to which input this switch must be connect. So this is decided by these select lines. So if these select lines are 0, 0, then D0 is selected. If we consider that select lines equal to 2, so it has a 2-bit combination. So it has a 4 different combinations. If they are 0, 0, then D0 is selected. If the combination of that select lines is this is S0 and S1, if we consider 0, 1, then D1 is selected. For 1, 0, D2 is selected, and for 1, 1, D3 is selected. So in this way we can select a particular input at a time using the combinations of this S0 and S1 select line. So here why these multiplexers are used or need. In most of the electronic systems, the digital data is available on more than one lines. So it is necessary to route this data over a single line. So under such circumstances, we require a circuit which select one of the many input at a time. So this circuit is nothing else but a multiplexer which has a many inputs, one output, and some select inputs. So if we take the example of a cable, on cable we have a number of channels, and we can select using a remote whatever channel we want to say, we can select a particular channel and that will be displayed on the TV. So there multiplexer is used. So that is nothing but the data selector. We can select a particular channel out of the number of channels available and we can able to see the particular channel. So the advantages of multiplexer, it reduces the number of wires, so it reduces the circuit complexity and cost, and we can implement many combinational circuit using mux. And it simplifies the logic design and it does not need the K maps and simplification. Okay, so there are a number of types of multiplexers are there, that is 2:1 mux or a multiplexer, then 4:1 mux, then 8:1 mux, 16:1. So these are the different types of a multiplexer. So first see 2:1 multiplexer and then we will move toward the 4:1 multiplexer. So let's see first 2:1 mux. So the block diagram for 2:2 mux, that means it has a 2 inputs and 1 output. So it has a 2 inputs, that is D0 and D1, and one enable input is there. This is 2:1 mux. It has a 1 output, and to select these 2 inputs we require one select line, that is S0. So plot the truth table. We have a different inputs, that is enable, that is E, then select line, that is S, or select input, that is S, then input D1 and D0, and here the output Y. So here enable is very important. This is the chip select input, or this is used to on the multiplexer. If we do not on, or if we do not enable this signal or input, then multiplexer will be off. So if this is the active low, if we make it 0, so the select line, this X means don't care. Whatever status of this select line, and D1 and D0, they also don't care. So output is 0. So nothing will be appear at the output Y. Whatever status of this D1 and D0, whatever data available on this input D1 and D0, that will be not appear on the output. That is, we have not applied the enable signal. Okay. Now apply the enable signal. Make this signal equal to 1. Now the multiplexer chip is enabled, and if the select line is 0, S is 0, this select line S0 is 0. So this will select the input D0. Okay. So if this D0 is 0, 0 will be appear at the output. Again, if the chip is enabled, now select line is again 0 and D0 is 1, so it will appear on the output lines. So this is a don't care. If whatever data is available on the D1, that will not be appear at the output, because of this select line status, it is 0, only D0 is selected. So the status of this D0, if it is 0, then output will be 0. If it is 1, output will be 1. That means here D0 is selected. Which input is selected? D0 input is selected because the S0 is 0. Now, if the enable is 1 and now the select line is 1. So as the select line is 1, it will select the D1 input D1. So if that is D1 is 1, so it will be appear at the output. And if this D1 is 1, that will be appear at the output. Now here this D0 is don't care. That means whatever data available on the D0, that will not be appear at the output because of this select line status, only D1 is selected. So in this way we can select, using this select line, a particular input, and whatever data available at that input, that will be appeared at the output Y. So this is the truth table. So now draw the K map. So here we have an input E and S0, then here D1 and D0. 4 inputs are there. Here E bar, S0, E S0 and E S0 bar. So we have to plot the truth table over here. Okay. So here output is 1 when here only 2 times. Okay. Now here this don't care means what? D may be 0 or a D may be 1. Don't care means whatever status of this D1, that is ignored. So D may be 0 or D may be 1 here. And here D0 may be 1 or 0. And here also D0 may be 1 or 0. So this 1 is for what? When the enable is 1 and select line is 0. Check the input. First check this rows input E and S0. So for this output 1, E is 1 and select line is 0. That means E S0 bar. So here E S0 bar. Now check the inputs D1 and D0. So here D1 is don't care but D0 is 1. So don't care means what? D1 may be 0 or a 1 but D0 must be 1. So here for here this row E S0, it is confirm over here, that is E is 1 and S0 is 0. So we have chosen this row E S0 bar. Now we have to choose the column. So here check for D0. So here D0 is present here and here. Okay, because it is 1. So no bar is there, so it is 1. Okay. And now D1 is don't care means here D1 is 0 and here D1 is 1. So for this both combinations output will be 1. Because here D0 is 1 and D1, whatever status of this D1 ignored, we have to check this. D0 is 1 for these 2 columns. So their output must be 1. Now check for this second output. Here again check E and S0. So E is 1 and S0 is 1. So this is the row E and S0. Now check the inputs D0 and D1. So check here D1 is 1 now and D0 is don't care. So D0 may be 1 or a 0 but D1 must be 1. So here we get here D1 is 1 and here D1 is 1. So for this row we get here D0, D1 is 1 and D0 is don't care. D0 is 1 or D0 is 0. We have to ignore this. We have to just check that D1 is 1 over here for both these columns. So plot this ones for these columns. So put zeros in the rest of columns. Now group. So here we get the first pair and here we get the second pair. So we get the output Y equal to. So for this, check for this pair, that is E S0 bar, and check here as this is constant for both these ones, and check the column here D1 bar D0 D1 D0. So here D1 is changes and D0 is constant. That means here D1 bar and here is D1. So it is changes from complement to uncomplement, and D0 is constant. So constant. To eliminate this changing variable and take the constant variable, so we get the first term E S0 bar D0. Now for the second pair, check the row, that is E S0, and here check the column. So here D1 is constant and D0 is changing. So take a constant variable, that is D1. So we get the equation E S0 bar D0 plus E S0 D1. So this is the required equation to plot the diagram, logical diagram for this 2:1 multiplexer. So here take the input E, then another input S0. So it is, we require both S0 bar and S0. So take two inputs. So this is S0 and this NOT gate will provide S0 bar. Now take the input D0, D1 and D0. So here our first term is E S0 bar D0. So there is an AND operation between these three variables. So E S0 and D0. So here we get the AND gate. For second term it is E, then S0. Now here it is S0 uncomplemented, so it is S0 line and D1. So here D1. Here also AND operation. And between these two terms there is a OR operation, that is addition. So here we get a OR gate. So this is the diagram for 2S to 1 multiplexer.